Good morning, students. Thank you so much for watching this video. I'm sorry I can't be there today, but Virtual Mr. Ripes is here to ensure that learning continues. All right, so this video won't take too much of your class time, but I do want to explain two more things to you real quick, so that way you can work on your study guide, work on studying for the first AP final exam, and complete those final two problems on the assignment that just came out yesterday, the Transformation Unit Practice 2. And this was a concept we didn't get to in class yesterday, so I want to make sure we're getting to it right now. So here we have this fish image, and according to these instructions, it's reflected in line K, which as you can see is right here, and then the fish is once again reflected in line M right here in yellow. Now, those two lines in which it's been reflected about make a 70-degree angle, as you can see. All right, so what we're trying to do is, according to these instructions, describe a single transformation that maps F onto F double prime. In other words, what would be the transformation equivalent, okay? The congruence transformation, like we were talking yesterday, about if you were to reflect an image over a line and then reflect that image over an intersecting line. Now, this only works if the two lines that you're reflecting about intersect. Check this out, everyone. Notice that the two lines intersect at a 70-degree angle. So the question is asking, what's the equivalent to a reflection and then another reflection? Do we have to call it a reflection still? No, we don't. Imagine we were to take a point right here, say at the end of that fish. And when it reflects over line K, that point ends up right there. And then you reflect it over line M, which as you can see is intersecting line K. The point now ends up right there. So if I were to draw a line from the point of intersection of the two lines to the first point on F, and that last point, F prime, does that have to be considered two reflections? No, because two reflections like this is an equivalent to a rotation of, and here's where it gets interesting, that 70-degree angle simply gets doubled, 140 degrees. So a reflection and then another reflection, as long as the two lines are intersecting, is the equivalent to doubling that angle. This is called the reflections in intersecting lines theorem. Okay, so I know this is a lot to look at right here, especially that diagram with all the arrows and the X's and the A's and the B's. Let me explain, okay? It says here, if lines K and M are intersected at point P, then a reflection in line K followed by a reflection in line M is the same as a rotation about point P. So a reflection, then another reflection, is just simply a rotation. Now, what angle is it being rotated by? Well, if the point that the two lines are intersecting at is X, well then the equivalent congruent transformation is simply double that angle. That's all it's saying. That's all it's saying. Here is one more example that I want to show you of this. From study guide page 42, here we have this key here. Describe a single transformation that maps A to A prime. And notice what's happening here are two transformations. There is a reflection about point line K, and then another reflection about line M. So two reflections is equivalent to what rotation is what this is saying. Well, here's the thing. We kind of already know the answer. Since the two lines intersect at a 60-degree angle, because we know vertical angles are congruent, this is also a 60-degree angle. So if I were to pick any random point on this key, and I were to draw it from that point to the point of intersection of the lines, and that point there would be equivalent, well, this would be like a rotation of not 60 degrees anymore, but simply doubling it 120 degrees. So in other words, a single transformation that maps A to A prime would be a simple 120-degree rotation, because it's simply doubling the angle in which the two lines intersect at. hopefully that made sense, because now you could answer those final 2 questions right before the exceeding problems on unit practice 2. What's the single congruence transformation? Well, if you know this angle is 55 degrees and you know this angle is 30 degrees, use that theorem that we just used to answer those questions. Now, that theorem will be proven, but we're not going to prove it formally using 2-column proof. No. I'm going to prove it to you on Monday using paper and Sharpies and a protractor, of course. Nice. All right, everyone. Hopefully that helped. Please reach out if you have any questions. Now, also handed to you was the first AP final exam resources to review sheet, just like you got in Algebra 1. This is done very similarly to Algebra 1, only this time it lists the topics that are going to be on the final exam for our geometry class. Now, once again, will it be every single topic from the first AP? No, that would make the test extremely long. This is going to be the most important topics from the first AP. Now, all the reasons that we're doing a final exam, keep in mind, from Algebra 1, that's the same reason we're doing it for geometry. So, the topics are distance and midpoint formula, very, very important formulas in geometry. Area and perimeter of polygons. Now, you'll have to use the distance and midpoint formulas to get those areas because they will be on coordinate planes. Measuring, calculating, and describing pairs of angles. Remember, we talked about pairs of angles, supplementary, linear, complementary, etc. Using those properties of equality, congruence, and postulates to prove geometric relationships, in other words, proofs. You know those lists of properties of congruence and equality and postulates? You'll have access to those lists again on the final exam, just like you did when you took the test. So hopefully those are still in your folder. Parallel lines, remember we talked about those and all the different angles that emerge from parallel lines cut by a transversal. And of course, perpendicular lines. Then, from our unit that we're currently on, composition of translations, congruence transformations, and similarity transformations. Now, we haven't talked about similarity transformations, but I guarantee that we will. And remember, whenever we say composition, all right, we mean more than one. All right, so we have to do more than one thing, more than one translation, all right, in order for it to work. And you'll just describe it like we've been doing. And that's it. That's going to be the whole final exam. You'll have the whole time to do it, of course. Please do come on time, so that way you get the full 45 minutes to complete. Because keep in mind, once you're done with that final exam, the day after that, well, that's Thanksgiving break. So we'll get it done. So I hope that helps. It's still going to be on the same date, Friday, November 21st. If I could ask you to, I recommend doing it before the final exam. Well before the final exam. In fact, even today. Do a self-assessment so you kind of know where you stand on these topics. So that way, here's the list again, how to prepare for a final exam. You can prioritize the I don't understand and I can do it with help topics first when you're studying. All right. So what you want to do for the rest of class now is work on that. I want to give you the rest of the time to work on this final exam resources to review, and then you can work on the transformation unit practice 2 and whatever else you need. So you got the rest of the time to kind of work on what you need, and I'll be available via Zoom all day. So feel free to reach out if you need. Thanks again, everyone. Hope you have a great day.